Good afternoon, and welcome to your final session of day one. Congratulations. So my name is Rob Crowley, and together over the next hour, we are going to attempt to solve a very pernicious question that's facing all API developers. Do we choose to build our API with REST, GraphQL, or gRPC? And along that journey, we're going to cover quite an amount of topics. So first of all, I want to make sure that we have a common understanding around some of the terminology that we use. So we're going to take a tour of API styles over time. So we're going to look at how our industry's thinking has changed. We're then going to look at a little bit of software architecture and see how we design systems and really take an outside-in approach to it. So we're going to look at architectural constraints and then the properties or the characteristics which will then be exhibited by the systems we build. From that, we're going to do a little bit of myth-busting. And we're going to look at some of the conversations that are happening in the API community today and cut through a little bit of the bold statements and a bit more of a nuanced view to what's happening. And then finally, with all of that knowledge, we're then going to look at some sample scenarios. And based on what we've learned and what we've discussed, then look at what an appropriate technology or API style might be for a problem. So before we proceed, a little bit more about myself. So I am a principal consultant at Telstra Purple, formerly known as Redify. So previous to that, I was the technical lead for APIs and authentication at Bank West. So the vast amount of my career has been in designing, operating, and running distributed systems. Until recently, for the last 4 years, I've been a co-organizer of DDD Perth, so WA's largest IT conference. And I'm available on the socials at Rob D. Crowley. So if there's any questions as you go through this talk, either come to me at the end or just reach out on Twitter. I would be delighted to chat to you. So why am I giving this talk today? Well, it's kind of a selfish urge, I have to admit. It's really a reflection on my Twitter timeline being an absolute tire fire. You see, when I really started getting into APIs, like when REST started to become en vogue about 2010, I started following all the luminaries in the industry at that time, so Mike Amundsen, Eric Wild, and everything was going great. I just took all of their information and, away I went. And then back in 2015, GraphQL came out, and of course I started following a whole new group of people. It turns out that these people don't agree a lot. So yeah, I see one person saying, this is amazing, and then I get 17 tweets or rebuttals saying, no, this is absolutely awful. And a lot of these conversations had no nuance at all, which just really left me feeling a little bit confused. So I went away and did a lot of research to get a more nuanced view on things. So I'll give you one example. So back in 25th of May this year, it's my birthday. So I was like, yeah, it's 2019. Why wouldn't we learn GraphQL? So I retweet this. 15 seconds later, Aaron Powell comes back and goes, no, it's just fancy OData. What are you talking about? And while this is a bit of a playful exchange, if you actually go through Twitter, there's actually quite acerbic exchanges or conversations happening there, which aren't positive at all. And it's not just on Twitter. On blogs as well. So going back to 2017, we've had very much a dialogue of people just saying SOAP is absolutely useless. We're not going to use it anymore. All of these APIs that we might have built over a decade, no, you don't need them anymore. We're all going to be building APIs using REST moving forward. And that wasn't just one article. We have another bold claim that REST is now REST in peace. So we're not going to use REST anymore. That's amazing, right? And then we're like, long live GraphQL. So, right, does all the knowledge that we have suddenly go to waste? And then you've sort of been thinking, history has this sort of tendency to repeat itself. And I'm pretty sure we've been here before. So if that's the conversation that happened in 2017, let's wind the clock back to 2010. And now suddenly, again, we have SOAP, not going to need it, useless. SOAP is officially dead. Wow. Say that to like 80% of APIs actually running in production today. And again, REST is going to come to the fore. So from those kind of commentary as well, the very much one-sided views in all these articles. So we probably ponder a couple of things there. So if SOAP is dead and REST is the new SOAP, does that mean GraphQL is the new REST? Yes, it's amazing. GraphQL is indeed the new REST part 1. I'm still waiting for part 2, by the way. But in all of these articles, which basically put forward one technology over another with very little nuance, what are we going to do as an industry? Do we just jump ship to the newest, shiniest thing? So what can we have learned from this? Rather whimsically, maybe we could just say we don't like XML and we move on. But there's actually a deeper problem here. Many of our API consumers are just deeply unhappy or unsatisfied and frustrated with the choices and the experience they are providing. And this actually has an important implication. So in the same way that history repeats itself, we've seen back in 2010 when people were declaring SOAP is dead and now it's REST. And now, 2017, 2018, 2019, we're having that similar backlash against REST, and everyone's saying GraphQL will come to the ascendancy. It's fair to say that if we don't actually tackle this properly, in 2025, there'll be a new shiny thing, and this whole cycle will repeat itself again. So really, one of my greatest hopes is that we, as an API community, are really quite small. We can't afford to take one-dimensional views on one technology or another. We really need to work together and really be able to grow our collective knowledge and have balanced conversations around it. But what if we can't do that? So what if we just suddenly said, oh, all these different text things, it's too hard. Maybe we just throw all of it away and start again. So we could have this world, maybe I'm a dreamer, but imagine there's no protocols, no hypermedia hills to die on, no media types. Wouldn't that be amazing? Wouldn't that be a wonderful world? Harmony? No, it'd be chaos. That's not the way that APIs work. We need protocols. We need standards. It's how we can understand different sides of the conversation. In the same way we need protocols and standards to drive how information is passed across the wire, we need to understand how we can talk as a community and have more fruitful conversations moving forward. Otherwise, we will be seeing something else again in 2025. This whole cycle repeats itself. So to gain that empathy for what's happened before, let's actually look at how APIs have evolved over time. And this time we're going to go right back to 1991 with a middleware called Corba. And back at the time, this was actually going to be the future of e-commerce on the web. And it was, again, an RPC framework, so a remote procedure call, so a term coined by Bruce Nelson. And it's effectively a way of one system calling a function in another system as if that network interface wasn't there. And yes, this was absolutely going to be the future, except it fell out of favor for XML. And you go forward to 1993, then we had remote database access. So you can think of this as SQL over the wire, so a way of querying data from a remote database. So again, you're probably thinking query language here. And in fact, as we go through this timeline, you are absolutely going to see common thinking, common patterns underpinning most of the API paradigms that we see. And actually, when we talk about some of the new things like gRPC or GraphQL, we can absolutely then get an understanding that these are building on the shoulders of giants. Fast forward to 1998, you have Microsoft release XML RPC, so a specification around RPC. So defining rules for the exchange so that we can have common understanding across the parties. In 1999, we have Don Box from Microsoft again, one of the people behind the 4 tenets of SOA, released SOAP. And this was really then what gained the ascendancy for quite a number of years. So it has WSDL again as the definition language for it. At this time, we're just starting to see the tipping point. So we're starting to see some of those frustrations around heavyweight protocols as well, a new age of lighter weight web apps being built as well. So in 2000, we had Droid Filtering release a seminal dissertation about REST. So again, building styles that actually embrace the web. And again, with this sort of SOAP and REST kind of going side by side, we're then seeing XML give way to JSON. So in 2005, RPC is still alive and well, but this time instead of XML, we have JSON. In 2007, we have OData. So very similar in terms of techniques as to remote database access all those years before, and it provided a query language where you can then express in verified detail what the client requires for a call. And then, based on this timeline, nothing happened for 8 years. So in 2015, then, we have GraphQL released. And again, GraphQL very heavily based towards the client. So again, the client being able to express the data that it wants and then receiving it back in one single call. So again, a lot of similarities to OData and remote database access before. And then most recently, we have the latest incarnation of RPC framework called gRPC. And while that's the technology view of things, let's actually look at what's happening in the industry over that time. So back in 2000, most of the APIs we built were just between two parties. So for a specific partner, and there'd be one-to-one interactions. So you will have a certain need, and I need to be able to talk to you, so I will build an API just for you. And a lot of things were file exchanges, so EDI, that sort of style. And then in 2010, with Web 2.0, there was a massive paradigm change. So suddenly e-commerce came along, and then you're looking at how can I actually build an API but have multiple consumers for it? So that's when you would have started to see Twitter release their APIs and that sort of time as well. And this is the second level of generic APIs. So instead of building for one person, we're trying to satisfy many different people with many different needs. And where are we going to go next? So if this is very much one-to-one, and then this is one-to-many, the next wave will very much be machine-to-machine, many-to-many interaction. So complex network or lattices of calls as well. So we absolutely need to get the automation in place and have agreement on how we best own and run these systems moving forward. And I still think we're some way away from that autonomous future, but I think that's a logical point for what we'll sort of see over the next 3 or 4 years. So across all those technologies then, again, what's the common routing or techniques underneath them? We have query APIs. So GraphQL and OData squarely fall in this area where you would have the client being able to define what data you need and when. You still have flat file APIs, so EDI, like electronic data interchange, where you might pass a file between two systems. And that's absolutely fine. So maybe payroll updates at the end of the month where there's rich sets of data, you just need to parse it from there. You don't need it to be real time. On the other side, then you have streaming APIs. So if you're doing media or files that has to be absolutely real time, you can have these other style of APIs. You have RPC, so again, gRPC being an example of that. And then web APIs, so where the predominant amount I would expect of the APIs that we would build as a group are. So that's where your REST APIs, your HTTP endpoint-driven APIs would generally fall. And I'm really sorry, but there is no universal best API style. So what are you thinking? I've stayed around till 6 o'clock at night just to be told there's no silver bullet? Sorry. But what I can say is there is absolutely a best API style for your problem. So of the different styles I've showed before, no one is inherently better than the other. It's really going to depend on the context of your problem. And really from there, we shouldn't be approaching a problem as I've heard a lot about GraphQL. I'd like to build a GraphQL API. It's understanding what fits your particular problem domain and then being able to decide what is the simplest way of not only building it, but also operationally moving forward for your product. What's the cheapest, simplest thing that you can do? And to get to that point, we really have to look at the software architecture side of things. So if we're going to look at the properties or characteristics of the system, and that might be performance, scalability of it, the security aspect of it, all of those properties, they don't happen by chance. They're outputs of the constraints that we place on the system. So for instance, REST has a number of constraints in it. So the uniform interface constraint, in that it says I'm going to have a consistent interface or canonical URL into any particular resource. And the property you would get out of that is simplicity. Simplicity from the interface such that there's a common entry point. But potentially as well, that means that there's some loss of efficiency because I've put an abstraction on top of it. So again, it's a trade-off. All of these constraints will mean you get one thing, but you miss out on something else. So they have to be deliberate decisions. And there's many different types of constraints that we may place in our system. So we might have business constraints. So we might have a customer, and they're only capable of consuming a file. So best of luck to us to try to give them a rich hypermedia API. We could either maybe convince them to change, or they'll take their business elsewhere. We might have specific product requirements around how it has to scale, how it has to maybe run from cost or simplicity around it. So these will all be unique to your particular domain. Likewise, we have technical constraints. So looking at the 8 fallacies of distributed computing, so understanding what are the various interchanges that are going to need to happen, what are the trade-offs, how do I build that ability for robustness or reliability, for instance, between those systems. And it might also going to be is how likely is it going to change? So do I have a fairly stable interface, or do I need agility to change to support new features, or potentially a pivot in my startup if I'm moving forward as well? And finally, the most interesting ones, it's all the human problems. So how well do we know HTTP, for instance? So if you don't have an intimate knowledge of HTTP, you're probably not setting yourself up for success to build a REST API, for instance, because it's predicated on having very strong knowledge of that underlying layer as well, because you're building on top of it. You also have to look at how your teams are supported around your products. So Conway's law says that the systems we build are always going to mirror the communication patterns in our organizations. So making sure that we've actually set up our teams around these API products to give them the best chance that they're going to be lead and support us moving forward. So once you have all of these constraints, and for every single system that I write down all of the constraints, and then seeing for this particular problem, which ones do I need to be concerned with? And that will be the mix of all of these business technical and socio-technical constraints, and that will then yield properties, not of the software system itself, but also of the wider support network around it. This is design, right? These are all the decisions about how we choose an appropriate technology or style for the problem at hand. And then Roy Fielding again, so the man behind REST, says that you're never going to have a style that's suitable for everything. But if you can compare architectural styles based on the properties that they're induced, it's way better than just choosing one at random. So this was actually my original premise for today's talk, was to come up with a framework that would allow you to navigate that, almost like a decision tree. And so it was a little bit disappointing to find out about 10 minutes into my research that someone's already done it. A man called Denik Nemec. So he gave the keynote at Nordic APIs last year, so 2018. And he does a very good critical review of REST and GraphQL. So rather than rehash a bunch of material that you can see on the web, and I'll include links for everything at the end as well, so no need to take photos as you're going through, you will see the quite detailed approach for how he methodically shifts between the two paradigms. So what are we going to do instead? So it would be a lot more fun, I think, to actually look at some of the conversations that are happening in your industry and potentially in your own workplace, and then to provide some of the underpinning principles to be able to cut through some of the cruft or hyperbole about certain items, and then be able to have more balanced conversations in your own workplace. So if you do want to introduce a new technology that's going to be perfect for that problem at hand, that you have enough detail or enough information to maybe counter some of the arguments or points that might be thrown at you. So let's look at the first one. So REST APIs are rest in peace APIs. Long live GraphQL. Or again, another prophet. So GraphQL will do to REST what JSON did to XML. So again, we will not have to worry about REST moving forward at all. And to do that, but we really have to understand what are these technologies actually comprised of. So as I mentioned before, all of these new technologies or styles are underpinned by things that we've been doing for decades. So in the case of GraphQL, it's really about remote database access, glorified, wrapped up around the query side of things, so giving the client the power to express their requirements. And then it's RPC on the right side, on the mutation side. So it's really those two concepts tied together with some of the learnings from HTTP and endpoint APIs, and that's really GraphQL. Like in a nutshell, that's the theory behind it. Then if you look at gRPC, it's quite different again. So in this case, it's very much about RPC, kind of a give me, but it's tied to HTTP too. So it makes a specific point around the transport. And it does that because it's very much focused on performance. And again, being able to avail itself of many of the features of that underlying protocol. And it uses protobufs for both the interface definition language, like the schema. So if you're thinking of maybe a REST API, you might be thinking Open API Initiative or API Blueprints or Rabble. Or if you're thinking GraphQL, then that would be the schema. So it still has a contract involved with it. And it uses that for not just defining it, but also the wire transport as well for the data format. So again, quite different. And then suddenly you look at REST, and REST is different again. So it's like, if GraphQL and gRPC are data, over the wire or data over HTTP. REST is very different. It's a state machine over HTTP or a workflow over HTTP. And I should state that we are not actually tied to HTTP, but practically for the vast majority of APIs that we be building, I will base this discussion as if we are talking across those protocol semantics. And just make it clear about what I mean about state machine is REST does require HTOS, hypermedia, as the engine of application state. So the server will generate affordances, which will then be processed by the client. And I don't want this statement to be confronting. If anyone's feeling a little bit uncomfortable, I apologize. But I think it's a very important point to make that a lot of the pain that people are feeling with REST APIs, I'm convinced it's because we actually kind of pick and choose maybe some of the parts of Roy Fielding's works that suit us. And when we don't actually adhere to all of the constraints, we actually sacrifice many of the properties that we would actually generate in our system. So it's just about understanding when you build a REST API that what we actually have to mean. I don't actually personally believe in like a Richardson maturity model because I don't think it's really helpful to have level 1, level 2. It's either REST or it's not. And that's fine. I'm not saying that to be confrontational, but I'll explain why it's important moving forward. And as I mentioned, I don't really want people to build kind of REST-ish APIs. I'm firmly convinced that an API where we loosely hold to some of the properties would actually be better written in either an RPC framework or as GraphQL. It doesn't mean that everything we do should be thrown away. It just means that you will generally get a far better outcome for the amount of effort that you would put in. And if you think about all of the other constraints that I mentioned before, like even a RESTish API still requires a fair amount of understanding of HTTP underlying as well. So there's still quite a barrier to entry to be able to build one that will evolve, scale over time. And as I mentioned before, there is that one style of API is not any better than another. It's going to be governed by your context of the problem at hand. So if your API is mostly actions, you can think about the Slack API as a great example of an RPC API, then follow an RPC framework. That is absolutely a valid choice. On the other hand, if you're looking at mostly CRUD, or workflow over HTTP and around manipulating related resources, then REST is a great choice. But again, understand your problem at hand and then work back to the technology. And if you're going to follow one person on Twitter, I do actually recommend Phil Sturgeon. He has a wealth of information around API design in general. And a lot of what I'm talking about now can actually be referenced in more details in some of the blogs that he releases. And even the creator of GraphQL says it's not perfect in all scenarios. So wonderful for client to server interactions, but for server to server, he goes, there's probably better options. Maybe gRPC or even REST is a better choice. So API styles, they all address different problem spaces. I'm a firm believer that RESTish APIs would actually be better written either as GraphQL or RPC. And gRPC is perfect for internal calls within your system as well, where performance is absolutely key. And if you want to learn more about gRPC, then I firmly recommend that you go to James Newton's King talk, I believe at 9 o'clock in room 3 tomorrow, but do confirm the schedule because it might have changed since I checked. What's another sort of myth that gets perpetuated? One of my favorites is GraphQL breaks caching. Full stop, just breaks it. And this is one statement that has absolutely no context at all. First of all, we should be asking, what kind of caching? Do we mean client-side caching? So that might be in the browser or your HTTP client. Or do we mean server-side caching? Or is it network caching, so in between the client and the server? So there's many different kinds. So if we look at HTTP-based caching, yes, we can absolutely do it on the client or the server side, often called application caching. But we can also use intermediary proxies like Squid or Varnish to hold that data close to the client as well, so shared caches. With GraphQL and gRPC, we don't have these intermediary caches. So GraphQL does treat HTTP as a dumb pipe and mainly uses posts, which won't be cached across the wire. But we can still absolutely use either a denormalized client cache or caching on the server side. So we really have to talk about what kind of caching. But why are intermediary proxies important? Because while the speed of light is fast, 300,000 kilometers per second, closer equals faster. So if you can get your data cached close to your clients, it's the whole edge computing proxy case as well, it will typically get to the client faster. And we can improve things a little bit with GraphQL, whereby you could use persisted queries with a get to allow you to actually issue queries with a verb that will be cached by the client. But it's not supported by absolutely all servers. So if you're in the Node ecosystem, so an Apollo server supports this quite nicely. And this is really a reflection of GraphQL being in its infancy. So in comparison to REST, which has been a rich history of problems being solved in the ecosystem over 10 years, GraphQL is still quite young. So there's still quite an amount of bike shedding around certain topics which have actually been solved in the REST space previously. However, there is another point to consider here. So authenticated traffic. So any traffic that has an authorization header. So if you've logged into a site, that will typically not be cached by intermediary proxies. So if you are dealing with personalized data, a lot of this argument might not be applicable for you at all. So if you are building a real-time API where the data changes quite a lot and all of the data is behind or tied to an identity, then you don't really lose anything from GraphQL with this caching story. So again, just understand not only the problem, the technology, but also what type of data, how quickly will it change. These are all things that could drive your choices. And while it might be an issue on one side, it might absolutely not be a problem for you at all. The other point to consider is the fact that the more customizable an API is, so the more power that you grant a client to request what the data that it requires, the less cacheable or the lower hit rate you will get for those resources. Makes sense. So if I have an API and the only thing you can do is /users/1 or /users/2, then yes, there's very low variability in that request, so you could have a high hit rate. But if you think about how GraphQL is defined, it gives all the power to the client to define what data it needs. So even if you can cache it, you probably won't get very high hit rate on that in any case. So the key takeaway, the more customizable you're making your API, probably the less value you will get from the caching side, at least in that intermediary store. So caching, many different kinds of caches, client, server, networking. Understand which ones are suitable for your problem. Highly customizable APIs benefit less from HTTP caching. If your data is mainly static and not personalized, then REST is a great choice because you can leverage network caching. And best practices are still absolutely emerging in the gRPC and GraphQL spaces. This is another one that gets thrown around a lot. REST APIs are inefficient. But REST was never about efficiency. If you look at what Roy Fielding was talking about, many of the constraints which he put in place are actively against short-term efficiency. And rather, it's about longevity. So APIs, World Wide Web, that will continue to evolve over decades and allow the client and the server to evolve independently. So that's really where REST is going. But when we say inefficient, in many cases, the conversation is actually about performance. So the chattiness, can you actually deliver that client experience with speed? And typically a problem that gets thrown at REST APIs is that about over or under fetching. So do you either retrieve too much data and send that back to the client at the risk of using too much of their data plan or limited bandwidth? Or do you retrieve too little data, forcing them to do many round trips? So often known as the N+1 problem. But there are techniques for this. So sparse field sets where the client can say, I only want this field, and this field is absolutely a valid approach as well. So while GraphQL has a really strong story in this area, it is nothing that we couldn't do with REST with a little effort. And then under fetching, what our typical response there in the HTTP 1 world was to use compound documents. So instead of just retrieving one resource or one representation at a time, combine many. And that's actually the underlying principle in JSON API or HAL, so Hypermedia Application Language, where it gives us a common vocabulary or syntax for embedding or creating compound documents. The GraphQL story is amazing because the client can express exactly what they want. We can get all the data, no more, no less, in exactly one round trip to the server. It sounds absolutely wonderful. And in fact, when GraphQL came out, this was really purported to be one of its major benefits. But as always, there's a trade-off to this. So by retrieving all of this data in a single call, we have now bound the response to the client to the slowest piece of data on the server. So if there are expensive fields that you're computing on the server side, the client will get no data until such time as that field has resolved as well. So there's always a trade-off in terms of the numbers of calls and the experience you want to provide. And so the GraphQL community looked at many ways that could overcome this. So again, Apollo led the way with deferred queries, where we could send back the initial response, and then we could annotate certain parts of our queries with defer, which means that when it actually becomes available on the server, we could then send a patch to the client as part of a multi-part HTTP response. And then over time, the client will continue to get all the data until such time as it has the entire object graph. But should it really be this complicated? We're just adding complexity over complexity. And what we're really looking to get around in this case is HTTP 1, where the cost of a handshake, both at the TCP and TLS level, is expensive. And in fact, reusing connections then consistently becomes a trade-off between how many resources do I use to actually create a number of pooled requests versus, again, the handshake and the time for all of that handshake and content window sizing to actually scale. So it's really about network hacks. So HTTP 2 absolutely solved this at the protocol level, at layer 7, where we can now have multiple multiplex streams on a single connection. In HTTP 2, we still have head-of-line blocking at the layer 4 level, so TCP. But upcoming, we'll have HTTP 3, which will solve it at that level as well by using UDP. So if anyone's followed Quick or any of the documentation from Google around that. So in the same way that Speedy became HTTP 2, we'll have Quick becoming HTTP 3. So that will allow us to gain a lot more efficiency in sending representations across the wire. But also it comes with another feature, so server push. So imagine, again, if we had a hypermedia-driven API where you get a root-level resource, and then afterwards you get all the children. So the server in that case could say, oh, if you ask for the root-level resource, then maybe I'll just push the children to you. So in fact, when the client then looks to retrieve that, it's already in their cache. So instead of request response, the server can then say, I will actually push prematurely those resources back to the users as well. And while this has been available from 2015, in fact, its primary use case was in the browser to load CSS and JavaScript for the browser. They actually found that prefetch links were actually more effective in that regard. But there's a lot of talk in the API community now about this being a potential kind of like perfect use case for some of the endpoint-driven APIs, allowing far finer-grained resources rather than the large chatty compound documents we had before, while still getting caching. So around performance, HTTP 1 was really the root cause for all of these compound documents, and in fact, one of the first selling points of GraphQL. So HTTP 2 removes much of the need for compound documents, so we can liberate ourselves from creating sort of large and potentially overfetching data. And server push does have a huge amount of potential for changing pieces or changing the way that we actually deliver content to the client, but it's not quite there yet. So there has been a library released this week called Volcane that actually promotes that use of the client saying, I would like these additional resources along with the root one, and then being able to push that data to the client, but profile use cases carefully. And in fact, people are so bullish about server push, they're now saying HTTP 2 makes GraphQL absolutely irrelevant. And this is just stuff I added today because there's actually been a lot of content this week about how much server push will change the API landscape. But just to call out that GraphQL is not just about network efficiency. It is far more than shaving a few bytes across the wire. GraphQL, or the value that it provides, is really the sum of its parts. So again, the schema is fantastic. But yes, you could actually achieve that through Open API initiative. Introspection is amazing. You can approximate that with hypermedia. So there's nothing really revolutionary around GraphQL, but it's really all of those different parts and taking a developer focus on it that adds that incredible intuitive and a low effort to get started with it. And if you really look at what developer experience then is, it's really about the docs that you can provide to your users, so understanding the shape and contract of your API. And then SDKs or client libraries for how you can consume it. And if you can get both of those right, which GraphQL does incredibly well, then that can lead people being able to consume your API. There's a rich ecosystem of tooling around as well. So code generation like type GraphQL to generate all of your TypeScript types off the schema as well. It's just a beautiful ecosystem. So when people say about GraphQL, oh, it's just about efficient network transfer, it's actually everything else over and above it that really makes it so special. So the true value of GraphQL, it lies in the tooling and the developer experience that it provides. Then again, though, if you're only concerned with network efficiency, then HTTP 2 endpoint may be a great choice moving forward. But this story will evolve and will continue to change over time. So another one, so GraphQL eliminates the need for versioning. You don't have to do it anymore. But we never actually had to do versioning. It was a strategy, not a requirement. And it was a strategy to allow clients to evolve at different rates and to dealing with breaking changes in the API contract. But there's other ways of tackling this problem as well. So instead of versioning, you can look at graceful evolution, which really underpins the concept of REST as well. So when Roy Fielding was asked, how should you version a REST API? He was like, don't. It wasn't a great interview. But likewise, GraphQL has taken the same point. It doesn't support versioning either. So really, both of these want us to look at this graceful evolution style. And again, from building APIs over time, supporting multiple versions is actually quite an expensive case as well. So it's really not in the providers or producers' side to support multiple APIs at the same time. So wherever possible, if we can achieve it with graceful evolution, then we should. But it requires discipline. It means we can't add new required inputs. We can't remove outputs or make them optional, because people might rely on them. We can't change the type of a field. So if before it was a number, we can't change it to a string, because there's expectations around it. And we really have to follow the robustness principle of Postel's law about only caring about the data that we want and not breaking if something else changes that we haven't expressed an interest in. And the key point here is you cannot over-communicate with your users. So if you are going to introduce a change, send a newsletter. Don't just rely on @deprecation or @sunset headers on your response. Create as open a dialogue as you can. Give them a period to say, this has been deprecated, and we will sunset it in 3 months' time. Allow them time to move it. So it doesn't mean you can't do breaking changes, but having communication between those is absolutely key. If, however, you have a client and you have no influence over their ability or rate to change, then yes, versioning might be a prudent choice there, but only if you can't exert any control or influence over your client. So don't start there would be my recommendation. And this isn't just about the server. It's also on the client side. So being a tolerant reader. So if the server decides to change the order of fields in the responses, don't break. If they add additional fields that you didn't expect, don't break. Like, don't do like serialization directly into a class. So really only look at the data that you want, independent of order. So again, it's about being well-behaved citizens on both sides of the network. And if you want to learn more about that, it's defined as an integration pattern by Martin Fowler as well. So he has a lot of great information about building robust integrations between systems. And GraphQL has a great story to tell in this case as well, so about deprecations. So again, we can mark certain parts of the schemas being @deprecated, and then any of the docs that the client sees, it can then see that this field has been deprecated. And also you know exactly what fields every user is using, so you know who to talk to. So that's very powerful in that case. So GraphQL does make it easier to manage graceful evolution, but it is absolutely possible with other techniques as well. An interesting observation that we should make here, though, as well, is that if an API has a sufficient number of consumers, chances are that someone's going to use every part of your API. So really understanding who uses what is actually not that valuable, because everything will be used by someone. And so then if we are making a certain change, you can also say it's not just about the schema of it, but people might have a reliance on certain other behaviors of it. So either like the speed or time or a number of other non-functional aspects as well. So if you're ever changing an API or looking at migrating it, we often have this case of like bug for bug compatibility. So someone will depend on behavior of your API, even if you see it as just fixing an error. It might actually be a breaking change for one of your clients as well. So again, there is absolutely no substitute for keeping that lines of communication open. And we can get the most value from our systems then by defining at that interface. So while I was talking a little bit about implicit behavior before, the best leverage that we can have for our systems is by the interfaces or the contracts that we create. So I would always advocate for a contracts-first approach, irrespective of the style that you have. So in REST, that can be Open API Initiative, API, RAML, any one of those things, but start with the design, start with the conversation, and then work from there. And what might a contract-first flow look like? So it might be in gRPC, that the protocol buffer file itself, or with GraphQL, the schema. After that's been agreed, you can have the client and the API being developed in parallel, potentially by different teams. And then finally integrated into a product at the end, and the whole loop continues again. But having that defined behavior in the middle is incredibly powerful, and that's where you look at all of these styles of rich ecosystems to allow either the mocking of data during development as well. So versioning, it is just a technique for managing breaking changes. It is not a requirement. It should be a last resort. Really prefer graceful evolution, and only if you cannot exert control over a client to change, then look at versioning. Absolutely not a substitute for communicating with users, and it also doesn't protect a user from requiring an implicit piece of behavior from the API that maybe it wasn't intended before, but has now become part of the flow. So always keep the lines of communication open. So domain modeling is only a concern for REST. So if you're building a GraphQL API, don't worry, it will all be good. That's not really the case, is it? So irrespective of the style that we have, you have to understand the API user's needs. So you always have to start with the users in mind. And this is where you really start with the contract as well. So if you have a user, maybe another team in your company, or maybe if it's external, try to have that design happening as fluently as possible at the start. But there is absolutely no escape. So if you're building GraphQL on top of a suite of existing RESTful services, GraphQL will give you one new chance to build the API you wish you had built the first time. But after that, you're into managing changes and deprecations and updates as well. So incredibly important that design irrespective of what we're looking at. And the interesting thing with REST is, with REST, we actually always start by defining the endpoints. So we have to start with how our users are going to consume this data. GraphQL starts a little bit differently in terms of we actually start defining the schema first and how those various types relate to each other. And then from there, the user will express an interest in a certain subset of that graph. So GraphQL allows us to delay the responsibility for identifying user needs until we actually start profiling queries. So from that regard, if you are a little uncertain about your user's needs for a particular API, or you are looking to support multiple different clients, say mobile, wearables, or desktop, that each have very different data needs, then GraphQL allows you to support multiple use cases in a single API again. But the payoff for that, or rather the downside, is GraphQL APIs are far more complicated to operate. And performance tuning can be a lot more onerous with them as well. So again, always looking at what's the simplest thing that you can do. So API design, there are no free dinners. It is absolutely table stakes, irrespective of the style that you have. So designing a RESTful API follows outside the inflow. So you start with the users start defining your endpoints, how they're going to consume the data, and then work back in. And then GraphQL allows us to delay the moment of profiling queries. So again, it allows us to deal with uncertainty a little bit more elegantly. Right, so looking at all that sort of information before, so we've talked about a lot of pros and cons of different styles as well. We're now, over the next sort of 10 minutes or so, going to look at a couple of sample scenarios, and then from there, hopefully have about 5-6 minutes to discuss them in questions afterwards. So taking our principle of choosing the absolute simplest thing possible for a given use case. So if I'm building a form, simple old web form, maybe registering for an event, and it's just CRUD, maybe it's a single client, then simply the simplest thing you can do is a CRUD REST interface. Like if you look at where GraphQL comes from, it's about retrieving many different shapes of data and doing that efficiently. If that's not a concern, then it's not going to be the right fit for you. Which might be a shame because you might go, I really want to build one of those APIs, but choose the simplest thing possible. However, a use case where GraphQL shines is a composite API. So previously you might have your SPA, and it's been calling multiple different APIs that it has to do all that logic to stitch that data together. Potentially has to deal with if one of those calls failed, does it retry all of that logic that was pushed to the client. GraphQL can absolutely shine here as an extension or a BFF, so actually changing that boundary between the client and the server, and putting a lot of that control over the server to then aggregate that data and just pass exactly the data that the client needs. So that's incredibly powerful as well. So if you have multiple different clients you need to support, then GraphQL can be an absolutely phenomenal chance or choice for that. And if you want a bit more detail about how you might go about building a composite API, I've included a link at the end to the talk I gave at NDC last year, which actually goes into actually building a server and React client in a lot more detail. But at a high level, that's effectively what it could look like. So it is absolutely not tied to having a REST API underneath it, but it could be any microservice, even talking gRPC, it could be directly to a database. So GraphQL does not care about the underlying data source. It is about querying the data that you need as expressed against the schema. But if that's about web, then what about maybe a native mobile app? And again, it's going to be in the control, so a BFF, so in control of that one product team. So again, maybe a single client. And the API is static and well understood. So maybe we know the shape of data, and it's not going to change a lot. So maybe a lot of those things that I spoke about before with GraphQL being able to delay that point where we have to think about the user needs. And from there, I'm actually really excited about gRPC in these cases as well. So typically, we've looked at it for just the communication between microservices, maybe within a bounded context. You can absolutely see it then becoming more pervasive across the stack as well. And obviously, this comes with quite a nice view as well, that you can have a single protocol end-to-end across your stack as well. There are absolutely some issues with this as well, with support for HTTP 2 on application servers as well, but the story is improving all the time. And also the fact with gRPC, being able to have a single protocol file and then being able to generate clients and service stubs in multiple different languages is incredibly appealing as well. So if you can standardize your runtimes within your organization, and teams are writing maybe some in Java, some in Rust, maybe some in JavaScript, then having gRPC being able to fulfill client libraries in each one of those libraries, and then maybe you host all your services in Docker, that can be a beautiful pattern as well. But don't constrain your thinking to just inter-service communication. And again, so that's a really nice kind of traditional pattern. I'm sure this is something that James Newton King will touch on in this talk, but from a .NET Core 3 perspective. One thing that might actually quite surprise you is gRPC in the web. So there is another project as part of that ecosystem that now says, how do we do it from the browser? It's not just about mobile apps. And that's actually achieved via running a gRPC proxy. So browsers themselves can't be just tied to HTTP 2. They can always be HTTP 1 traffic as well. So if you get into like the Chrome debugger, you can actually see what's being passed across the wire. So what that does is convert between the potential HTTP 1.x traffic and then allow it to flow into HTTP 2 on the back end. And again, I expect this story would improve over time. But if you're keen to have consistency in protocol end-to-end, then that can be quite appealing. So what did we cover in this talk? So at the very start, we looked at a lot of the dialogues or questions that's happening in the API communities today, and we've seen that there's very little nuance in those conversations. So we looked at some of the architectural styles over time, and what we've really seen is that the same ideas have been coming up or arising time after time, just with different badges or different technical names around them. We then looked at, to design systems, we really have to think about the behavior that we want from the system, and then actually work back to say, what are the constraints, or what are the invariants that we can apply during design time that will yield those characteristics? And again, we need to be deliberate about that. We then took a quick wild world through all of the conversations that are happening in the team. And really my goal from that is to give you that level of detail such that if those conversations or similar ones are arising in your organization, that you can start asking the right questions or raising the right points to be able to get to a good outcome moving forward. Then at the very end, we looked at a couple of examples. So really what my goal from there is not to give you an exhaustive list of use cases and patterns. There is a huge amount of material out there, but rather get you thinking about what are the systems that I'm designing. With this information, would I do something slightly different? Or is it just confirmation that, yes, I've made the right choice? But it's about making more informed choices moving forward. So it's been an absolute pleasure to talk to you this afternoon. I hope you enjoyed it, and I hope to see some of you on the boat cruise. Thank you.